In this lesson, we shall solve question 5. The graphs of f of x equals 2 over x plus 1 plus 4 and parabola G are drawn below. C, the turning point of G lies on the horizontal asymptote of f. KC on the horizontal asymptote of f. The graph of G passes through the origin. Clearly, here's the graph of G passes through the origin. B with coordinates k and 14/3 is a point on F such that BC is parallel to the y-axis. You can see clearly that BC is parallel to the y-axis. Right, write down the domain of F. We can see F is this, and therefore the domain is clearly X, which is an element of all real numbers such that X itself is not equal to -1. Because we understand that the hyperbola is, or the rectangular hyperbola is undefined when x equals -1, and so this is the domain. The x-intercept of f is next. So we've just done 5.1. Right, 5.2, the x-intercept of f. So to deal with 5.2, we're interested in the x-intercept. Right, x-intercept of f. And to find the x-intercept, we clearly let y be equal to 0 in f. So that we have 2 over x plus 1 plus 4, which equals 0. 2 over x plus 1, which equals -4, which means that 2 is minus 4x minus 4, which means that you have, if you transpose the -4, it becomes 6, which is -4x. And this is 6 over -4, which equals x. And this means that x is -3 over 2. And the x-intercept of f, therefore, is x equals -3 over 2 over there. And that is the answer. And this can also be written in different ways. You can also say x is -3 over 2 and y is 0. Or you can say it's -1.5 and 0. Or x is -1 and 1/2, okay? Next, we determine the value of k in 5.3. Right, to find the value of k in 1.3, we recognize that k appears here and k appears there as well. Right, and now in 5.3, we note that the point B has the coordinates k and 14/3. And which means, therefore, that f of x is 2 over x plus 1 plus 4. This is x and y. Y is 14/3, which means 2 over the x is k plus 1 plus 4. 2 over k plus 1 follows, and then we have the following. Right, so we transpose, and we have 14/3, and we subtract 4. This is 2 over k plus 1. And what do we then do next? We simplify this here as follows. Okay, so yeah, this is exactly 14. And what is 14 over 3 minus 4? It's actually this one, 2/3. Cross multiplication gives 3 times 2, which gives us 6, which equals 2k plus 2. Right, so that now 6 minus 2 is a 4 equals 2k, and which means that k is equal to 2 upon division by 2, both left and right. So now we have to find the value of k here, and clearly k equals 2. We need to write down the coordinates of C. You need to write down the coordinates of C. So to write down the coordinates of C, there are a couple of things that are very important. But first things first, we realize that k is equal to 2 there, right? So if k is 2, and you recognize that C is actually the turning point of G and lies on the horizontal asymptote of F, and clearly the horizontal asymptote has the equation y equals 4. Right, so that the coordinates of C themselves are x is 2 and y is 4. Okay, we understand, therefore, that this point C is such that BC is parallel to the y-axis. If it's parallel to the y-axis, it means x is the same at B and at C. So the coordinates of C are exactly exactly 2 and 4. Next question, we're looking at 5.5. 5.5 is we are given this particular equation, but we understand that it is the equation of G, and G is the parabola. And now we have that it must be in the form A, open bracket, x plus p squared plus q. But most importantly, to do 5.5, then it passes through the turning point. Right, this G has the turning point C with coordinates 2 and 4, which means that y is actually 4 and x is 2, which means that y is equal to x minus 2 squared plus 4. Okay, so it passes through so that now you have 0 minus 2 squared plus 4. 0 equals 4a plus 4, which means you have 4a. And divide through by 4, which means a is minus 1. Which means, therefore, that we have minus into x minus 2 squared plus 4. So what is the equation? So clearly the equation then is minus open bracket x minus 2 squared plus what? Plus 4. That is the equation of f, and we are, or of G rather. That is the equation of G, the parabola there. Okay, so we found it. Okay, next we do 5.6, because the parabola once again passes through the origin. Okay, the origin O with the coordinates 0 and 0. Next we do 5.6. Right, to deal with 5.6, in 5.6 we are dealing with f of x over g of x is less or equal to 0. And now here we're going to deal with what we call the signs, which means that we have positive, negative is negative, which is less or equal to 0. Or negative over positive, which is negative, which is less or equal to 0. So that in the end, then what do we have? So we need to analyze this graph, these graphs f and g, and now look at a couple of things. Like we know very well that this one is minus 3 over 2. Right, so in 5.6 then, if we have this inequality less or equal to 0, let us look at the signs associated with this. So this part of the graph is the positive part, and this is the negative part. The negative part is below the x-axis, and the positive part is above the x-axis. It's above like this. And this is below like this. Right, so, and this is above like this, above like this. So that in the end, then what do we have? For which values of x will this rational result be less or equal to 0? Right, and we can see that clearly this graph, this parabola continues, although it crosses, this parabola G crosses the asymptote. Okay. So now, but it's negative all the way. So if x therefore is less or equal to minus 3 over 2, because when we take the x values right through, let me use a different color here. Let us use a different color. So if this passes through this here, then you have the negative part and the positive part, then you have x less or equal to 0. Right, and here then you have that both parts are negative here. But now here at -1, you have a negative part here and a positive part there up to the y-axis. So which means that from -1 to 0, from -1 to 0, the G is negative and the F is positive. After the 0, they are both positive. And then now from this, okay, this point here, we understand that x is 2 because the coordinates of C are 2 and 4. So this is the line of symmetry, the axis of symmetry, right? Dealing with what we call the axis of symmetry, the couple of things that we consider here. Okay, so, right, if the distance is 2 units here, it's also 2 units here, giving us 4 and 0. Right, so that in the end, then what we're able to get is as follows. Right, so this one is 4 and 0. Now, which means we have that, or x is bigger than 4. Because when we go to the right of 4, then 1 is positive, the f graph is positive, and g is negative. We just need different signs, okay, there. So this becomes the solution to the problem. But I want to just comment on this here, that indeed at this point we can allow the f graph to be 0, meaning that at -3/2 where f is 0, that's okay because this equals 0. But g is not equal to 0 at -3/2. But at -1, we can't allow x to be equal to -1. So these inequalities are strict because the function f is not defined at -1, but also most importantly, what we have is that g itself here is 0 at the origin when x is 0. So yeah, we cannot allow x to be equal to 0. But x here is strictly is greater than 4. But can x be greater or equal to 4? Because this is less or equal to 0. Well, we check that. But whenever we can allow x equal to 4, it means g is going to become what? It means g is going to become 0. G 0. Okay, because that is what g is. It has an x-intercept there, which means that y is 0 at x equal to 4. So that we actually need a strict inequality there. So this is indeed the correct answer to 5.6. And then look at 5.7. The next thing is to look at 5.7. To look at 5.7, there are a couple of things that we need to obviously begin to consider. Right, what do we consider? Right, we've been given the question 2 over x minus 5. Right, let's write it properly. So it's 2 over x minus 5, then what? Right, 2 over x minus 5 is equal to minus x minus 3 squared minus 5. So what then do we do now? We consider the function, this function f there. And so we recall a couple of things. Right, we recall that f of x is the same as 2 over x plus 1 plus 4. And g of x is the same as what? Is minus, open bracket, x minus 2 squared plus 4. So that in the end, then what do we have here? I want to therefore compare. We're going to do it in green color. So now we're going to have 2 over. The examiners perform transformations because we can see that the function f is x plus 1, but now it has just become x. So 1 was subtracted. And then you also have that the original function f has a plus 4, but it has become minus 5. So it's minus 9 because 4 minus 9 is minus 5. And this equals minus, open bracket, x minus 2 minus 1, which is minus 3 squared. And then this is plus 4 minus 9. Right, so that in the end, then this is what we have. Right, so what is then the answer to this? Right, so that in the end, then we get this particular result here. And this becomes the answer to this question. Right, it becomes part of the answer, or at least some steps, rather, towards the answer. Right, so what actually has happened? So we're able to see a couple of things, that this part here, this part here, this part here, and this part here are sort of the transformations. So in other words, we will make, and we're able to make the following observations. What are the observations? The observations are that f and g are shifted. Right, so f and g are shifted. How are they shifted? 1 unit, 1 unit right. But also, F and G are shifted 9 units. 9 units downwards. Right, 9 units downwards. All right, so if they are shifted clearly 9 units downwards, what then is the next thing that we need to do? Right, so they're shifted 9 units downwards. Okay, so that is the transformation. What is the next thing that we need to do? Right, we also are able to make a couple of observations about this. Okay, now when this happens, let us draw the graphs, and we draw them in a different color. Let us draw them in green color. So the couple of things. So we shift the graphs 1 unit to the right to get something like this. And then now we shift them 9 units downwards to achieve this. Simultaneously, this one is shifted 1 unit to the right, and then 9 units downwards, so that you have something of this nature. Okay, something like that. Now, what then are we able to achieve out of this? We understand, therefore, that this graph here is going to intersect like this and touch here. Okay, so it's going to sort of cut. And when it cuts like this, there are a couple of things that remain very important. So you'll have a single point of intersection after the movement of 1 unit to the right and 9 units downwards. So in other words, you'll be able to make the following inference. What inference are we able to make? And this is what we're able to say. Right, so we are able to say that they only intersect. Right, they only intersect in the third quadrant. They only intersect in the third quadrant. Therefore, there's only 1 point. 1 point of intersection. So yeah, it's going to be this point where these graphs meet. 1 point of intersection. Right. And the conclusion, therefore, is that use the graphs to determine the number of the real roots. And therefore, we have 1 real root. One real root. So in other words, we have 1 real root in the end. Because the question was, determine the number of the real roots of this equation. So there's just only 1 real root. Right, and we've solved this problem step by step. Thanks everybody for your time and watching, and goodbye to you. Goodbye.